चलिए आज का होमवर्क हमारा स्टार्ट करते हैं, जिसमें हमें फाइंड करना है कि द इक्वेशन ऑफ टेंजेंट टू सर्कल, पैराबोला, एलिप्स एंड हाइपरबोला. सो लेट्स स्टार्ट विद सर्कल. So we all know that the equation of circle is x square plus y square is equal to r square. Taking a standard circle for, it's a very bad circle. Taking a standard circle, is this a good one? This is the radius. So this is the radius. Now the point which we take here is xy. Now we have to find the equation at x1 and y1, which are tangent to this. So let us consider a point anywhere which is x1 y1. So equation will be x1 square plus y1 square is equal to r square. So no problem with that. So now the thing which we have to do is differentiate this equation to get the slope of tangent of this equation. So when we differentiate this equation, differentiating with respect to x, the first one, okay, the first one, differentiating 1 with respect to x, we get 2x plus 2y y dash. We can take divided by dx as y dash. Here I am taking it. So is equal to r square, is r is a constant in a circle, so it is 0. So changing this side, 2y y dash is equal to minus 2x. 2 get cancelled. Y dash is equal to minus x upon y. So what is y dash? Y dash is the slope of tangent of this curve. We say this equation as the curve. So the slope of the tangent, we have got m1 is equal to dy by dx. I'm just writing the same. Now what we have to do it at a point x1 y1. Here is the point. Let's take this as x1 y1 at x1 y1. So just substituting, so we'll replace x with x1 and y with y1. No big deal here. Minus x1 upon y1. So m1 is the slope of tangent which we are getting here, which is minus x1 y1. Now we know from point slope form that we need a slope and a point in a given line to find the equation of the line. So we are getting here slope and the point is here with us, x1 y1. So the point is here. Now we have to find the slope of the, so equation of tangent is given by y minus y1 is equal to m x minus x1. Here x1 and y1 represent the point, and by means these are the same, x1 and y1. So let's take that y minus y1 only is equal to m minus x1 into y1 is equal to x minus x1 is equal to minus x1 plus x1 square. Here it's minus y1 square, and here it is y1. Yeah. So y1 from the equation plus x1. Here just I am changing the side here, is equal to x1 square plus y1 square. This y1 gets here, so it's x1 square plus y1 square. Now when we see here, x1 square plus y1 square is r square. What we are getting here is x1 plus y1 is, here we have proved that x1 square plus y1 square is r square, so which is r square. This is the equation of tangent to the circle. Let's shift towards parabola. So equation of parabola is y square is equal to 4ax. Okay, we have to prove this for x1 y1 only, for the point x1 y1 only. Okay, so let's start. So same procedure here as well, as x1 y1 is the same, is a point on the same parabola whose equation is given here. So substituting y1 square is equal to 4ax1 Okay, for point x1 y1. Okay, so here we get it. Y1 square is 4a x1. Okay, so now let's differentiate this equation which is y square is equal to 4ax. So let's differentiate it with respect to x. So it will be 2y y dash is dy by dx is equal to 4a. So to do 2a, y dash, which can be written as dy by dx, is equal to 2a upon y. Okay, we have to follow the same procedure which we have done here. Find the differentiation which gives us the slope of tangent, which is m1, and then we have the point which is given to us x1 y1, and then substitute in the given equation for the tangent. The same procedure is to be followed everywhere, regardless of the shape we are given. Just we have to find we have to know the equation of the shape which we are given. So dy by dx is 2a upon y. Okay, so now this is the slope of the tangent. Okay, yeah, so this is the slope of the point which we are going to take, but this is the slope of the tangent. This m1 is we are taking as the slope of tangent at a particular point, which is dy by dx at, we have to find at x1 y1. So I'm taking here x1 y1. So now substituting just x with replacing x with x1 and y with y1, we have to do the same thing, 2a and y with y1. No x here, so no x1 will come. m1 is 2a upon y1. Okay, done. So now the equation of tangent. For equation we need slope and we need a point. Point is given here, x1 y1. Here it is. Yeah, so at x1 y1. Yeah, so the equation of tangent is given by y minus y1 is equal to m x minus x1. Y minus y1 is equal to m. We take 2a upon y1. I substitute. I change the side, x minus x1. Let's open the bracket. Y1 minus y1 square is equal to 2ax minus 2ax1. Yeah, see, in circle we had the equation x square plus y square is equal to r square, right? The equation which we got for the tangent, of tangent which got was x1 plus y1 is equal to r square. So we are getting somewhat similar equation, right, from here. So in the same way here also we will get a similar equation to the equation of parabola. So now we know from here we did it, y1 square is equal to 4ax1. Let's substitute it here. So y1 minus 4ax1 is equal to 2ax minus 2ax1. Now we know this 4 goes this side and 4 minus 2 is 2. So it is 2ax plus 2ax1. This 4 goes this side and y1 is equal to 2ax plus 2ax1. So what we get at last is 2a into x plus x1. This is equation of tangent for a given parabola. So just substitute the points here. That will be our answer. Let's take the third one, which is okay. For third one, ellipse. The equation of ellipse is x square upon a square plus y square upon b square is equal to 1. Okay. Yeah. So x square upon a square plus y square upon b square. We have to find it at a point x1, y1, which we are given here. Okay. So x1 and y1. So let's substitute. So for a given ellipse means egg. Sorry, ellipse. I'm telling you egg. Okay, so this is the point xy for a given ellipse. So this is the point x1 y1. Any random point is x1 y1. So this will have the same equation for the ellipse. So in the same way for x1 y1, the equation is x1 square upon a square plus y1 square upon b square is equal to 1. Okay, so let's start. Let's differentiate this first equation. We do it everywhere. differentiate in 1 with respect to x. It is 1 by a square is constant, so I'm taking it out. 1 by a square into x is differentiation of x square is 2x, plus 1 by b square, I'm taking again it's constant, so I'm taking it out, into 2y into y dash. Y dash is divided by dx as always. 1, the differentiation of 1 which is a constant is 0. So okay, 2x upon a square plus 2y y dash. So taking it this side, so 2y y dash upon b square is equal to minus 2x upon a square. So now changing the side, y dash which is dy by dx is equal to minus x b square upon y a square. Y dash is dy upon dx, which is slope. Now let's take the slope of the tangent of the given point which we are given. So for the given point, the slope of the tangent which we take here m1, slope of tangent m1 is equal to dy by dx at a definite point at point x1 y1. Here we take m1 as the slope for the point x1 y1, which will be like this. Yeah. So taking that, now just replace x with x1 and y with y1. So it is minus x1 b square upon y1 a square. Wow, what an equation! What a slope for tangent. So for the equation of tangent, two things are needed. One, the slope of tangent, which we got here, and one, the point, which is x1 y1. A very famous name now, it has become x1 y1. So okay, the equation of tangent is y minus y1 into m, which is minus x1 b square x minus x1. Okay, and here it goes a square y1. Okay, so now just multiplying it, a square y1 minus a square y1 square is equal to minus x1 b square plus x1 square b square. Now let everything be positive here. As we think positive, it happens positive. So a square y1 plus x1 b square is equal to a square y1 square plus x1 square b square. Now if we see here at this both the cases, we got what we were just deciding. Means we took the equation of circle as x square plus y square is r square. What we got was x1 plus y1 is r square. What we took here was, means the equation of parabola is y square is equal to 4ax. What the answer we got for the equation of tangent is y1, means obviously y square. We can tell if we compare it here is equal to 2a into x plus x1. If we take both of them as x, then it's 2x, so it's 4ax. So these equations are not contrasting, they are complementing each other. In the same way, we need equation as such as x square plus a square plus y square plus b square, like something like that. So what we'll do is we'll divide with a square b square here. So dividing with a square b square, a square b square. So okay, so here the first one was a square y1 square, so y1 upon b square plus x1. Here it was b square, so it's b square get cancelled, so it's a square is equal to y1 square upon b square plus x1 square upon a square. Okay, so see from the equation which we got here, x1 square plus by a square plus y1 square by b square is equal to 1. Let's substitute it here. Let me minimize the noise first. Okay, I minimize the noise. So y1 upon b square plus x1 upon a square. Why do these kids cry at night only? Y1 upon b square plus x1 upon a square is equal to 1. This is the equation. See, these equations also complement each other. They are just like the same. Yeah. So this is the equation of tangent for an ellipse. Let's move towards the fourth one, which is hyperbola. Hyperbola. So the equation for hyperbola, for a standard hyperbola, is x square upon a square minus y square upon b square, which is equals to 1. Okay, if you notice here, it's the same technique we are gonna do it here. No change in that. Even I can tell you the answer, it will be here minus here. No change in the equation. Yeah, I can bet that. Still we have to do this, and so we'll start. Yeah. So this is the equation for hyperbola, which we give here 1. Now we know hyperbola is like this. So for a point xy, the equation is this. But for point x1 y1, the point is x1 square upon a square minus y1 square upon b square is equal to 1. This is, we have to just substitute it at the last like this. We are doing it for that only. No other use for, of this equation. Okay, so let's differentiate this first equation, differentiating 1 with respect to x. We get 1 by a square is constant, taking it out. 2x square differentiation is 2x plus, sorry, minus it is 1 upon b square into 2y, y dash is dy by dx is equal to 0. Changing the sides, we get 2x upon a square is equal to 2y, y dash upon b square. 2 get cancelled, y dash is equal to x b square upon y a square. Sorry. dy by dx is x b square upon y a square. This is the equation, this is the slope of the tangent at a given point. Now let's calculate the slope of tangent at a given point which is given to us right now in this question. So m1 is the slope of tangent at x1 y1. So slope of tangent dy by dx at x1 y1 is equal to, replacing x with x1, the same procedure followed, x1 b square upon y1 a square. M1 it is. Yeah, we know equation of tangent and all that we have to write here. Equation of tangent is given by y minus y1 is equal to mx minus x1. Okay. Yeah. So y minus y1, same. I'll fetch it from the last page. X minus x1. x1 b square upon y1 a square. y1 a square x1 b square. Okay, let's open the brackets. y1 a square minus a square y1 square is equal to x1 b square minus x1 square b square. Let this equation look very positive and energetic. A square y1 plus b square x1 is equal to a square y1 square minus x1 square b square. Sorry, it's the same, no difference. Okay, so dividing by a square b square. Yeah, so y1 upon b square minus x1 upon a square is equal to y1 square upon b square minus x1 square upon a square. Now the equation which is here is here it is. Yeah, it is here. x1 square upon a square minus y1 square upon b square is equal to 1. So we will substitute that here. But wait a minute. It is okay. So but this is minus 1 because here it is x1 square upon a square minus y1 square upon b square, but here it's y1 square minus x1 square, so it's minus 1. Minus substituting it here, so it is okay, minus substituting it here, it's x1 upon a square minus y1 upon b square, which is equation of tangent for hyperbola. TYSM. Thank you so much.